This is the demo for College Algebra, Lesson 15. Let's start today by making sure we have all the right answers on the summary at the end of our previous lesson activity. So if you have not completed that lesson activity, definitely go back to that. And you can watch that video if you want to review and make sure that you have all the right answers. So number one, summarize our basic transformations. So if f of x is our quote-unquote parent function, and g of x is a transformation of f in that we've added some stuff and we've multiplied by some stuff, by some constants, we want to know, we're going to asking a bunch of questions about this transformation. So which of the constants move the function? Shift it around. So shifting happens via addition or subtraction. So it would be the c and the d. Shift the function around. And which of the constants change the shape? So the shape changes by stretching or compressing, and that happens by multiplication by a constant. So the a times and then b times, so the a and the b change the shape. Which of the constants affect the graph horizontally, either by moving it or changing its shape? So horizontal changes to a function happen inside the function. So inside the parentheses for f, so b and c will change the graph horizontally. And which of the constants affect the graph vertically? Those are when you have constants outside of the function, so a and d. And then finally, compare the effects of the constants that change the graph horizontally and those that change the graph vertically. So when you change a graph vertically with the a and the d, so whether you're stretching, shrinking, or shifting up and down, you do exactly what you think you should do. It's intuitive. So when it says plus d, that means move up d. If it says times a, that means all your y values get multiplied by a. So if a is big, the y values get bigger. If a is small, like a fraction, then your y values get smaller. But when you do horizontal changes, horizontal transformations, that comes from changes inside the function. Those are always counterintuitive to what you expect. So when you see plus a number, that actually means it moves the graph left that amount. And when you multiply by b, if b is big, it actually makes your x's smaller. And if b is small, a fraction between 0 and 1, that's actually going to stretch all of your x's. So this horizontally are counterintuitive. They do sort of the opposite of what you'd expect. So to do multiple transformations, you first change the shape of the graph, both vertically and horizontally, and then you shift it or move it around. Horizontal and vertical transformations are independent, so it doesn't matter whether you do horizontal or vertical transformations first. The only thing that matters is that you do the shape change first, then the shifting. So you'll note when if you read the textbook that it gives you different instructions to what we've written here. I would like you to follow these directions. They will better prepare you for your next math courses. The two methods are equivalent. Your book presents transformations like this, whereas our notation will factor out this b. So if you distribute this b, you would get bx plus bc. So they leave that b factored in, so p is really bc. So I always like to write it like this: factor out the coefficient on the x, and then you follow these rules. So we will not be filling in all of the blanks on this question, but I have a transformation of f. G is a transformation of f. And instead of a, b, c, and d, like in the previous question, I have actual numbers here: 2, a quarter, minus 3, plus 4. So we want to answer all these questions. All of the y values are shrunk by a factor of. Okay, so y values stretching and shrinking, that would be an outside multiplication. So this times 2, because it's outside, it is exactly what you expect, and it's going to stretch the y values by a factor of 2. So we don't have any shrinking of the y values. The y values are stretched by a factor of 2 because of this times 2 right here. And then it says all the x values shrunk or stretched, and by what factor. So we have to look inside the function for changing of x values. And we're multiplying the x's by 1/4, which your intuition would say, okay, that's going to shrink your x values by a factor of 1/4, but because it's inside or horizontal, it's the opposite of what you think. It's actually going to stretch your x values by a factor of 4, the reciprocal of 1/4. So all the x values are stretched by a factor of 4. And there is no shrinking of the x values. Okay, all the x values are moved up or moved, all the y values, do they move up or they move down? So the up and down is vertical, so we're looking outside the function. This +4, it's exactly intuitive when you're outside the function and making a vertical change. So this +4 means up 4. And nothing moves down. And then all the x values, do they move left or right, and by how much? So I look inside the function, left and right is horizontal. So I look inside the function, it says x minus 3. Your intuition might think that that's left 3, but it is the reverse. Whenever you're inside the function, making horizontal changes, it's the opposite of what you think. So it's not left 3, it's right 3. All the x values move right 3. And they don't move left. All right, given the table of values for the function f of x, we want to create a table of values for the function g of x, which is 2 times f of 3x plus 1. So there's 3 transformations happening here. We've got a times 2, a times 3, plus 1. We have to figure out what all of those do, and then we're going to figure out what happens to each of my points, and then we'll finally fill in this table at the bottom. So 3 steps to the transformation. We can start with the horizontal. There's only one thing inside, and it is a shape change. Okay, so f of 3x is a horizontal shrink. Okay, because it's times 3, makes you think it would get bigger, but it actually shrinks. Where we multiply each x value by 1/3, the reciprocal of the 3. Okay, it says times 3, but it actually means divided by 3, or times 1/3. Okay, now we're going to perform the vertical stretch, which will multiply the output values by 2. So we have times 2 outside, so it's a vertical stretch. And then finally, we apply the vertical shift, which will add 1 to all the output values. So we're going to do this for each of the points. So 6, 10, the first thing I do is multiply the x value by 1/3. So 1/3 of 6 is 2. 1/3 of 12 is 4. 1/3 of 18 is 6, and 1/3 of 24 is 8. I did nothing to the y. All I did was multiply my x values by 1/3. Okay. Next transformation, we multiply the y values by 2. Okay. So my 2, 4, 6, and 8 stay the same. I'm not changing them on this step. I'm doubling the y values on this step. So I get 20, 28, 30, 34. And then the last step is I apply the vertical shift, which is add 1 to all the y values. So again, my x values aren't changing on this step. I'm adding 1 to all the y's. So 221, 429, 631, and 835. So my final table of values is going to be 2, 4, 6, 8 for my x's, 21, 29, 31, 35 for the y's.